Hello everyone, and welcome to the MLOps workshop. In this video, we will be discussing the Onyx format. We will walk through what it is and why it's important. So what is Onyx? Onyx stands for Open Neural Network Exchange, and it's essentially an open format built to represent machine learning models. I believe it was originally started at Facebook. They wanted to unify models created with PyTorch and Caffe. Then Microsoft and Amazon got involved, and now there are a lot of companies investing in this technology. Some of them are IBM, Intel, NVIDIA, Sony, and Unity. So what does this format give us? It allows you to develop a model in your preferred framework without worrying about downstream inferencing implications. If you have watched my previous videos, you will recall the N by M mess caused by this one-to-one mapping between frameworks used to build models and tailored deployment solutions. We previously discussed how this is not a manageable approach, and Onyx helps solve this problem. There are two main components to the Onyx format: converting a model to the Onyx format and the Onyx runtime. We will start with the Onyx format conversion. So we have a trained model in PyTorch, and the next thing we need to do is convert it to the Onyx format. How do we do this? PyTorch actually has a built-in functionality for exporting a model to the Onyx format. You can use this by calling torch.onnx.export. The result of this command is a binary protobuf file which contains both the network architecture and parameters of the trained model that you exported. If you're unaware, protobuf is a popular serialization method that was developed at Google. So now we have a model in the Onyx format, but what do we get from this? It turns out that one thing you get with this format is a common representation of your model's computation graph. Under the hood, deep learning is accomplished through computations over data flow graphs. This graph serves as an intermediate representation, and at the moment, most machine learning frameworks have their own proprietary representations of the graph. The Onyx format is working towards standardizing this. Now for the second component, serving a model. For this, Onyx provides a designated runtime. The Onyx runtime is an implementation of the format specification, where the primary objective of the runtime is performance. The runtime is also a cross-platform tool. When it comes to the Onyx runtime, we go through two main steps. The first is we create an inference session. When we create an inference session, we are also loading in the model and creating an in-memory representation of the graph protobuf. Then the Onyx runtime goes through a graph optimization process. For example, maybe dropout gets eliminated from the graph because it's not a necessary node at inference time. There's also a process known as fusion, where certain operations are fused together. If you want to learn more about the Onyx runtime graph optimizations, I suggest you look at their documentations. It's a very interesting concept. There are even options to partition a graph into specific groups of actions that should be run on specific hardware accelerators. It seems like the options available to us at this step can get really low level. And again, I suggest looking at the documentation. Now for the second component of the Onyx runtime, execution. The execution can be accomplished by calling the .run command. As of right now, it seems that there are two main modes of operation. The first being sequential, and the second being parallel, where it will run the computation graphs in parallel if the operations allow for it. This brings us to the end of the Onyx format overview. It's a really cool piece of technology, and I highly recommend you look into it further. In later videos and during the workshop, we will be taking a hands-on approach to save a model of the Onyx format and serve it through the Onyx runtime.